The purpose of this video is to give an overview of the sensors, software, and two different dashboards used in this project. The sensors used in this project are the Tobii Pro Glasses 2 eye tracking system and the Cognionics 64 electrode EEG cap with PPG, GSR, temperature, and ECG sensors. The overlap between these systems is the measurement of human autonomic responses. That is, responses that predominantly occur unconsciously. In this project, we utilized a variety of open source packages such as EEG Lab, PyQt5, and BM3 developed by Mintz at UT Dallas. BM3 integrates independent biometric sensing systems and procures three key products. 1. An analysis-ready data store. 2. Tailor-made computational tools for biometric research. And 3. Post-collection visualizations. Here's a general overview of how data preprocessing works in BM3. First, raw data is read into the directory structure using a read function, which creates an analysis-ready data table. Then, multiple data tables from different systems for the same collection period can be integrated using a synchronize function, which outputs a common timestamp data table with quantities from both input tables. Here we have a breakdown of the directory structure of BM3. BM3 consists of 5 subdirectories: backend, codes, objects, raw, and visuals. Backend stores files that makes BM3 work. Codes has the open source code for the library functions, which can be used as is, expanded upon, or augmented with custom functions. The objects subdirectory organizes the analysis-ready data structures. The raw subdirectory houses all the unformatted data straight from a biometric sensing system. Visuals saves trial-specific visualizations such as plots and videos. Files in the objects, raw, and visuals subdirectories are organized by a dataset ID, which is a string that uniquely identifies a dataset. An ID is defined by the year, month, day, trial, user or participant, and device corresponding to a dataset. An example is shown here as 2020_01_01_T01_U000_device ID. Notice that the path at which files are saved corresponds exactly to the dataset ID. This enables BM3 to process and look up data structures automatically without necessarily bringing them into working memory. Visualizations are a powerful tool in analysis. This dashboard shown here is available out of the box in BM3. Here is an example script of how to create the dashboard. At the top here, it is a good practice to clear the workspace, clear all figure windows, and clear the command window, but this line is optional. 2. We use the home dir function, which adds all BM3 functions to path and changes the working directory to BM3. Next, we define the dataset ID. Here we have 2019_12_5_T03_U010. Next, we can use the decode ID function to convert the ID string to input strings such as year, month, day, trial, and user. Next, since we need data from two separate devices, Here we define those device IDs separately. First, the Cognionics Mobile 128 system, given as EEG1, and the second is for the Tobii Pro Glasses 2, Tobii01. These device IDs can be customized by the user for their specific application. Next, the visualization performs clustering of data records using the self-organizing map algorithm. So we need to specify the shape of the map we want to fit the data to. And finally, we can create the dashboard in one line using the visualization video 1 function. The previous visualization may not always be the right fit for a specific analysis. That is where the creation of custom visualizations becomes helpful. Here we have built-in functions that create modular visualizations which can be integrated to create new user-defined visuals, such as visualize bar, which plots any quantity iteratively on a bar plot, or the visualize PD function, which creates the pupil diameter and gaze direction visualization seen in the previous dashboard. The second dashboard used in this project is an open source real-time biometric data visualization application. This application allows the researcher to gain insights in real time as opposed to waiting to the post-collection phase. Not all analysis and visualizations can be computed in real time, so the visualizations and analyses shown here are much more lightweight than in a post-collection dashboard. Next, we will go through a case study utilizing the sensors and software packages presented here. Thanks for watching.